Right, this been going out again. Let's turn it off. All right, recorder on. Yes, move on to the next question. Question 4. The superposition introduction is quite simple here. It says that the superposition is the stated that in any linear network, more than one source is present, then we can, oh, this is very long here, cannot put it into one sentence easily. Superposition theorem is a circuit analysis that is used to solve network where two or more sources present at the corner. It's actually to solve the another theorem they offer for the circuit analysis to help you solve a circuit network with more than one sources. You know, let's say you have one current source, one voltage source. You can easily use a superposition to turn off one of them, and then you can slowly work on one step at a time, and then first find out the first variable, then proceed to another variable, and then eventually you sum all the variable together to find the actual output you want. This is something that it can do for you. Okay, let's see how can we apply this theorem on this circuit, on this simple circuit. Okay, let's copy this thing here before we forget here. All right. Then we come to procedure 1. Okay, I think from now on, because this is such a simple step, I want you guys to try on your own about half an hour time, say half an hour time. You try on your own, you read through it. Okay, you try to do it on your own, and later we come back. I'm going to check whether you're correct or not. Okay, later come back, I will quickly simulate in front of you also. But I'm going to simulate very fast. I will not go through step by step like this. Okay, so make sure you go through it, and because I want to give you the chance to try out by yourself. I don't want to, you know, to guide you step by step for every question. I think it's time for you to try to be independent. You know, try to read the instruction yourself and try to see if you can follow or not, and to solve this question or not. I hope the instruction is clear enough. Let me simply read through it, whether this the instruction is clear enough for you to do or not. Find the V out source. Wait, what's the name? Find V out when the source for Q. Okay, so it means you want to find the V out. Q mean what? Q for A and 6 volt. That means turn this off. Okay, turn this off. Remove I1 and V1, and then measure the V out. Okay, I think it should be okay. I think try to follow it. But the instruction is a bit simple. Usually, should be more detailed. But I should give you a chance to try out. Don't worry if you make any mistake, because that's how you learn. After you make a mistake, then you know how to, then you can remember the correct steps easier. Okay, I'm going to leave you to try out this one for yourself. LD Spice, right? LD Spice also. Previously, I said that they're going to use online software, but not for this assignment anymore. This assignment still using the LD Spice from question 1 to 5. In the past, we need to use a separate software, online software. But this time we are all using the same software. You know, they change it. Okay, I just found this morning. They didn't use online software. They all using the LT space. Okay, guys, I'll leave you here for a while. I'll come back to show you the correct simulation result. I hope I can do that. All right. Okay, please do the this question 4, and later we discuss about this question. Okay, I'm going to simulate on my own. So I need to try it. Let me turn off the share screen so I can simulate on my own. Okay, please do it yourself. I'm going to turn off the share screen and mic also. Right, I'm back. Okay, I will not show you how to prepare your reports, but instead I'm going to show you how to do the simulation. Okay, let's look at the simulation question again. So this is the one. Okay, and I think the first step what we need to do is it, let me make sure the recorder is on. Okay, we want to find out what is the V out on this original circuit. Then we apply our superposition theorem to find the V out also. Make sure they are tally, the result are tally. So the first of all, we need to draw this circuit with all the component in and to see what is the actual V out. Okay, so let's go ahead and do it. What we have a current source, voltage source. Okay, let's start from the current source. I think let's start from current source. So this would be question 4. Okay, let's start from the current source. So what can I do here? I think I just go ahead and remove all this register and leave the last one. Okay, remove everything here. Leave the how many we need? 1, 2, 3. Okay, never mind. Okay, let's find the current source. Edit component. Let's find the current. Start with C. Okay, so this is the current source. What we need is a DC current source. I think the default one should be a DC. So we're going to rotate this one. Make sure it's pointing upwards. Okay, just rotate. Go ahead and rotate this. Control R. So we're going to place somewhere at this side. Okay, push at this side. Never mind, we place here. It's okay. Then adjust it. Adjust the. Enter the new value, 6 ampere. Okay. Then another one here on the top. Okay, let's get another one. Edit, component, current, rotate. The Q pointing to the right hand side. Pointing to the right hand side. Then this one is a 4 ampere. 4A. Okay. Then we borrow this one. We press F7 and move this one to here, I think, parallel to this current source. So we place here. And let's borrow another one. Place here, somewhere near here. Okay, another one is here. Rotate. The thing is near here. Right, so we have 1, 2, 3 resistor, and then the last one is the power source. And then we need the ground also. Let's move the ground here. I think we can just go ahead and delete all those lines. Make sure it's not affect our simulation result. Like pan over there to the center. Move this one also. Okay, now let's connect all the wires. Let's connect all the wires now. Wait, you need to click on the icon. When you see the crosshair, it means you are in the wiring mode. So here I should connect this one first. Then this. And I think you can do it just like that, you know, without any problem. Here, another one. So this will be our PR point. Okay, later we want to find out the voltage here. This original circuit without using any theorem, just find the VR. You put a line here without the line is still the same, you know, it doesn't make a difference. Okay. But I still need to insert the text here. The text just for reference only, it will not change the simulation results. So it's a 6 volt now. Let's modify to 6 volt and change all the value to 2, 3, 1. Forget about the ohm. We need the ohm. Is it? Double check. 4, 6, 1, 3, 2, 6. 4, 6, 1, 3, 2, 6. Okay. Now let's run the simulation. So the V out, let's click on this node to find the V out. So it's a 10 volt, right? You can see that. If you want to see for sure, press F7 and move the text away. Okay, so this will be our reference before we apply the superposition. Okay, the superposition is for the manual calculation. This is not for the simulation. This is a simulation. This is our reference. So we go ahead and cut this one as a reference. It's a V out. Okay, so you have to prepare yourself all the procedure. Now at the results, I place the original circuit here. Okay. So on the first step, now let's apply the superposition. Q 4 ampere and 6 volt. So what do we mean Q 4 ampere and 6 volt? Let's see, let me see. 4 ampere and 6 volt. Let's see another. Okay. 4 ampere Q it means delete it. 6 volt also delete it. But we still have this resistor here. We cannot just leave it open. That means no current flow through. This one has no effect. Therefore, we need to connect a wire. A wire. This one, I think just leave it open. Okay. Now let's run the simulation and see what is the output right now. You see now we have only one current source. Only one current source with the remaining components. Okay. Let's see the superposition. Step 1 and run it. So we get a 2 volt. Okay, so V out to 2 volt. Let's cut this one out. Let's cut this one out and place it under the step 1. Step 2, I think. Step 2. No, wait. Divided into step A, B, C. Okay, let's follow exactly the same. Now this is the start of our step. A results follow. Let's copy it. Forget about the question mark there. It's confusing. Forget about the question mark. Keep 4 ampere open. Replace put with a short wire. Okay, this is the clue actually. This is a clue. Where is it? Where's my previous sentence? Okay, so really clear that the V out is 2 volt only. But don't worry, we just call this one V out 1. V out 1 is equal to 2 volt. Okay, we need to continue until we have 2 more voltages, 2 more. So B is what? B is remove I2 and V1. Okay, remove I2 and V1. So we come back here again. We need to recover back, right? Let's see Control Z can recover back or not. Let's see the Control Z. Let's see we can undo it or not. F9, undo. Okay, now we're back to original circuit. Now we need to remove I2 and V1. Where is I2? Let me see. Where's I2? I2 is here, V1 here. Just now we delete this one, this one. Now we delete this one, this one. Okay, we leave only the I1, I2 and V1, right? Double confirm again. I2 and V1. Okay, let's do that. Let's remove this one and this one. Okay, but we have to keep the this one connected, right? The voltage must be connected after you remove it. The current, just leave it open. The voltage need to using a short wire to replace it. Okay, now we run it again. I think this one should change. Let's run it again. Okay, now become 4 volt. So let's cut and paste this thing. Cut and paste under this. Reduce a bit. All right, now it's out number 2 is forward. Okay, now we're down to the last possible configuration. First, let's recover back. Okay, let's press the F9 to wait. Let's press the F9 to recover back. Now we just need to delete the last one, the last combination, I2 and I1. That means we leave the power source on only, the voltage source on. Okay, first copy the instruction, C. So this one you have to keep the message here also using the same message. Keep the what's the voltage there? 6 amp open. replace 6 volt with a short wire, for the same. And then for this step, we remove these two wire, remove these two current source. We leave only the voltage source here. Okay, and see what is the output. Run it. So we got 4 volt here. Okay, let's copy. 4 volt. Put it down here. So what is the conclusion? I think it's quite obvious, right? V out 3 is equal to 4 volt. Therefore, V out 1 plus V out 2 plus V out 3 is equal to 2 plus 4 plus 4 equal to 10 volt, what we expect to get, right? So this is similar with the circuit, original circuit. What we mean original circuit is that the circuit without using the superposition. So original circuit show that it's a 10 volt. By keep everything in, it should be 10 volt. But if we use a superposition, we remove two source at one time, and then we sum all the voltages, the output voltages, then we should come to the same result. Even though we have do it 3 times, but this is for the circuit analysis. I mean, when you use a piece of paper, if you can throw out these two sources, leaving only the current source, it's easier for you to analyze it. With only one current source, this one's with only one current source, this one with only one voltage source, it's easier for the user to analyze. If you present the user with the complete circuit, it's sometimes difficult to analyze output voltage here, like this. With all the current source and voltage source in, it will take longer time. So the superposition can help you save some time if you can break into 3 circuits, and then at the end you just sum all the output voltage, then you will get the same. You expect to get the same result. Okay, this is what superposition about. Then after you've done this, you also need to prepare the discussion also and conclusion also. Let me see, is there any question or not? Let me see. Yeah, there's one simple question. Compare. It just asks you to compare the observation. All right, that would be you cannot just bring like this. If you bring, you'll get a 0 mark for this section. So make sure you write your own. Okay, that you write your own discussion and write your own conclusion. All right, I think that's about all for the this simple one, the circuit experiment 4 or the laboratory 4. Okay, now we left the last one, question 5. So I'm going to give you some time also to go through question 5. Question 5 should be slightly longer than question 4, I think. Let's see the question 5. Just a few steps more only, What question 5 about is the maximum power transfer. Okay, let me give you some background information about this maximum power transfer. And this is quite important concept also, especially when you come to the exam time or the assignment, how to calculate this maximum power transfer. Use the correct form. Okay. Let's see. Don't forget about this one. Try to be consistent. Maximum power transfer. Let me give you what the maximum power transfer is. It's temporary, just borrow it. Okay, just borrow it. Okay, let me explain to you what happened here. So you see, what maximum power transfer mean is that assume you have a circuit like this. You have a voltage source, and then you have the internal resistance in a spatial configuration. Okay, you can have many resistance here, doesn't matter. Okay, and then this is your output. For example, this is your output. Let's call it A and B. Okay, so eventually, just like other case, you're going to connect this one to the external load. You're going to apply the external load to the circuit, okay, to this circuit. So this is the original circuit here. So the original circuit is here under the dotted red line. This is the original circuit. Okay. And this one is the external, we call RL. So what maximum power transfer theorem can do for you is that we need to convert this one to the somehow a simpler one. Let's say convert to VTH. Let's say we convert to VTH, plus and minus, and then we reduce all these component resistor into only one. Let's call the RTH. That's why the Thevenin becomes so useful right now, because it helps us to convert the circuit into only two components. Okay, so now if the user asks you, if the user asks this question, what value of RL should I use to make sure I have the maximum power drawn from the circuit? So what is the appropriate value for RL to ensure maximum power output? So you can apply different RL. Some RL will leading you to the some output, let's say in watt. Okay, some RL, different RL can lead you to the different output at certain watt. Okay, what we want is the what exactly is the value that to ensure the maximum power output. Okay, the maximum only. We don't want any output. We want the maximum output. What is the maximum output you can draw? So the answer is very simple. If the RL is similar to RTH, then you can achieve the maximum transfer. Then we call it the P out of RL is going to be maximum. Okay, you can do a simple test if you don't believe it. If you don't believe this idea, you can do a simple test, a quick one. Let me show you a quick one. Okay, let me show you a quick example. For example, you have a Thevenin circuit like this. Let's say 10 volt, and then let's say you have one ohm here. Okay, this is your original fixed circuit. So this is your external one. So you want to find out which RL can get the maximum output. So let's say you put it, the ohm is double the RTH. Okay. So the power output here is equal to, first you need to find the wait. Let's make it easier for us. Okay. Let's convert this one to 4 ohm, so that later when we divide it's easier. Okay, let's calculate the current now. So the current is equal to V over R. Only one voltage is 10 volt over the total resistance, 5 ohm. So the current is 2 ampere. And then the power can be absorbed by this 4 ohm is I square R. That means 2 square and then times the 4. 4 times 4, 16 watt. Okay. So if you make this one smaller, that means it's the 10 volt. Remember the 1 ohm is the fixed one, you cannot change. If you make this one smaller than 1 ohm, that means the 0.5 ohm. So let's calculate again. I equal to V, the same V over R, 1.5. Okay, let's calculate the I. Is it getting higher output or what? 10 divided by 1.5, you get 6.67. 6.67 amp, and let's calculate the power output. Is 6.67 square multiplied by what? The ohm, 0.5. Okay, what's the value? Looks like higher. Feel like it's higher. 6.67 squared multiplied by 0.5, you get 22. So looks like it's higher, right? It's higher, you get a higher output, higher than the 16 watt. So 0.5 looks like there is a way to go, right? How about you try 1 ohm? Let's try 1 ohm. 1 ohm and another 1 ohm. Okay, so let's do it again. I equal to 10 over 2, 5 ampere. P, 1 ohm equal to 5 square plus 1. So it's 25 watt. Do you see that or not? You say that by making the RTH similar to the RL, we can achieve maximum power transfer. This is not maximum yet. These are even lesser than the other two. So that this is the basic theory behind the maximum power transfer. Then when you come to the last experiment, we have the circuit like this. Of course, the first step is to reduce to the something like RTH, something like this. Reduce only one resistor and one power source, so that we can apply the different output, different load. Okay. So which one is our load exactly? I think our load should be this R. And most of the time, the RL looks like on the right-hand side, right? We already used to that. Most of the time, the RL used to be on the right-hand side, but not for this case. This time, the R, our loop is already located in the middle between A and B. This way we place our external component. Okay, so this one's This is not our output, right? This cannot be output. This is the current source. So the AB here, terminals, is where we place our load resistance. Okay. So somehow you need to remove this one first and find the equivalent circuit using the probably using the Thevenin theorem, and then eventually you're going to see to get the maximum output, the RL need to be equal to RTH. Okay, and then whether you can prove the theorem or not, can prove the theorem is valid or not. Okay, so I leave you guys to try this out on your own. Okay, so I will come back about half an hour later to go through with you. Okay, to make sure you have your simulation result is correct. Okay, so I'm going to leave you guys try this. Okay, just follow the step since you already know the theory behind. Okay, just go ahead and try this one. First, you need to construct this circuit without the R. R is unknown, you see. R is initially is unknown. That means is the user decide the output resistance, not the designer only design these internal parts. Or the user decide on the final resistance for the R. So make sure you don't include this R in, even you try to include this R in is without any value. So I think it's impossible for you to simulate, right? So just put the AB like this. Okay, so you guys go and try it. Okay, try question 5.